Alright guys, let's talk about lesson 5, which is mole-to-mole calculations. When we think about reactions, I want you to think about them like a recipe. So let's look at this recipe, which some of you might be familiar with. A mix plus 2 eggs plus 1 cup of water will yield a cake. So the mix, the 2 eggs, and the cup of water are your reactants, and the cake is your product. So when you're thinking about a recipe, just like a recipe in a chemical reaction, you can double or triple or even half or any other multiple of the amounts of the ingredients to change how much of the product you can make. So for an example, if you get 2 mixes, you make 2 cakes. If you use 6 eggs, you'll get 3 cakes, so on and so forth. So how do we do that in a chemical reaction? Well, we do that by using what we have are coefficients. So we have coefficients. Remember, those are the numbers in the front that we use to balance chemical equations. And they tell us how many moles of a substance are needed in a reaction. So we're going to do the same step method that we're using in the past. Instead of using like 1 mole is 22.4 liters, or 1 mole has 6.022 times 10 to the 23rd atoms, or 1 mole has a certain amount of mass, we're actually going to use the mole ratios in the balanced chemical equation. So we're going to do the same 3 steps that we've been doing all along. So let's look at the example 1. So it says how many moles of oxygen are consumed when 0.6 moles of hydrogen burns to produce water. So this is the reaction where hydrogen will burn in the presence of oxygen to produce water. So step 1, what do we want? It's asking us for how many moles. What are we given? We're given 0.6 moles of hydrogen. And what do we know? We know that based on the coefficients from this balanced chemical equation, for every 1 mole of O2, we have 2 moles of H2. And that's what we're going to use to convert from one compound to the next. So we're going to set it up like we've been doing in the past. So 0.6 moles of H2 times 1 mole of O2 over 2 moles of H2. Moles of H2 are going to go away, and we're going to be left with 0.3 moles of O2. Let's look at the second example. How many moles of nitrogen gas, N2, will be needed to produce 10 moles of ammonia, NH3, in the reaction? So our reaction is listed. Okay, so what does the question ask? We want to know how many moles of nitrogen. We know how many moles of ammonia we have, and we know based on our balanced chemical equation that we have 1 mole of N2 for every 2 moles of ammonia. So what happens is we start off with what we're given, apply our conversion factor. So we want moles of NH3 to cancel, so moles of NH3 have to cancel, so they're going to go in the bottom, and that's going to be equal to 5 moles of N2. Alright, let's look at this practice. Okay, so if 12 moles of C3H8 react completely, how many moles of H2O are formed in the reaction below? So we have C3H8 plus 5O2 gives us 3CO2 plus 4H2O. So we want moles of water. We have 12 moles of C3H8, and we know based on our coefficients we have 1 C3H8 for every 4 moles of water. So how do we arrange this? Okay, we're going to start off with 12 moles. Then we're going to arrange so that our moles will go away. And then when we're done with that, we get our answer, which is 48 moles of H2O. Let's look at another practice. So if you have 20 moles of CO2 are formed, how many moles of O2 react in the reaction below? So we have C3H8 plus 5O2, giving us 3CO2 plus 4H2O. We're going to use the same equation from before. We're just going to be looking at things a little differently. So we want moles of O2. We have 20 moles of CO2, and we know that we have 3 CO2s to 5 O2s. So when we set this up, this is what we get. We get 33.3 moles of O2. Last practice, we have 3.75 moles of aluminum to react with how many moles of sulfur are needed. So we want moles of sulfur. We start off with moles of aluminum. We know that there are 16 aluminum to 3 sulfurs. So we're going to set this up. And when we do our math, we come up with 0.70 moles of sulfur. So let's look at check your understanding. We'll go over this one in class.